Okay, and I should probably share my screen, shouldn't I? Okay, let me flip this thing over so I can write. Okay, there we go. So now we're ready to start officially. Anyone has any questions before we start the lecture? Yes. We can do that. You mind switching those lights up? I think it's this thing that looks like a switch, but it's not. Yeah, okay, thank you. Okay, guys in the back, everyone can see the board? Okay, perfect. All right, so now I need to remember to point here and not on the board because we need to see the pointing in the lecture slides. Cursor is there. Okay, you can see everything in the video. Okay, so we start. Let's just get straight into it. Right. Again, as I mentioned before, a word of caution: if you see things that look too easy, too good to be true, it probably is. But remember, you still have to read it to remember certain words. Right? Just for multiple choice questions that will come out. So let's get started by defining a whole number. Okay, I should also mention these notes are based off of the module manual. Right, so I just basically took the module manual, I screenshotted a lot of things, and I put it here in a sort of orderly way. I may have switched things up a little bit, like here, for example, I put another definition which needs to be here because we need natural numbers to define whole numbers, for example. So you might find a bit of correction done in the lecture notes that's not in the module manual. So just take note of that. Okay. Oh, there's a lot of crap in the module manual, which I'll tell you guys as we get to those places. You can skip this, you can brush over this quickly. So take note of that. If you read something which seems like nonsense, it probably is. But if you're not sure, you can ask me. Okay. Okay, so defining whole numbers, we need to first define natural numbers, and this is very straightforward. Natural numbers are the numbers that come naturally to us when we try to count. Like, for example, if I want to count how many computers are on this table, I'd say 1, 2, 3, 4. Right? You start from 1 and you go all the way up, possibly to infinity. 1 to infinity, those are the natural numbers. Right? The name is fitting, it's easy to remember because of the name. You guys good with that? Natural numbers. Okay, now because we know what natural numbers are, we can define whole numbers very easily. Whole numbers are just natural numbers with the inclusion of 0. That's all it is, right? 0, 1, 2, 3, 4, all the way to infinity. Those are whole numbers. Okay. Number system, again, I skipped a lot of stuff here because they go into too much of detail. A word we need to remember is a digit. We know what digits are, but if you forget the word, just the recap is here. All of these 0 to 9, these all represent digits. Right? These are digits. Just remember what that is. Place value and place value chart. Again, simple stuff, but we need to know technically what it means. So place value chart, we'll start there. It's this kind of chart here which helps you to read very big numbers. Right? You see, it's just basically labeling the place value of every number. Every individual thing here is a place value. So the number 1456, it's easy anyway. But let me show you guys an example where the place value chart becomes necessary. Right, so that's an easy example. Suppose I try to read this number on top. Right, if you just look at that number, it's easy to read immediately. It's a bit tricky, right? I believe that you guys, if you look at it for a while, you can work it out. But what they're trying to show you here is using this place value chart, it becomes a lot easier. Right, so let me try to jot this number down into the chart. Let me see if I can zoom in a bit here. Just a little bit. Okay. So let me see. If I make a mistake here, just correct me. I'm going to try and write this number in the chart. It's 2 from this side, 5, 4, 6, 7, 9, 8, 6, 5, 3, 2, 4, 1. Okay. That's the number. Now, would you agree it's a lot easier to read this number once it's in the chart? I'll give you guys a few seconds to try to read this number out in your head. Then I'll try and read it here and try not to make a fool of myself. Let's see what happens. Right. Give you a few seconds. Try and say that in your head. Few seconds. Okay, that should be enough. Let's check how much easier it is to read now with the once it's in the chart. We start in the trillion, so this looks like 1,423,568,976,452. Right, quite straightforward. Quite straightforward once it's in the chart. Okay, so what I'd ask you guys to do is just become acquainted with the way this chart looks, right? What's on top here and what's at the bottom. Just have an idea so that if you're asked, like in the multiple choice question, they may give you something like this in places of something and ask you which one is correct. You know, strange things to catch you guys out. So just have an idea what these look like. And there's another example at the bottom here, which you guys can try at home if you want to get more practice with this. Now again, more words to remember here. You probably know these things by experience of seeing them, but maybe you haven't seen these names before. Standard form and periods. Anyone seen these names before? Okay, perfect, right? So we're learning something new. A bit boring, but something new, right? Definitions. Standard form, okay, it's a notation where we separate numbers into groups of 3, like this right here at the bottom. This number here, 1, 2, 3, 1, 2, 3, blah, blah, whatever that is, that number is in standard form because we put commas between every group of 3 numbers. Right, and every group of 3 numbers is called a period. It's as simple as that, right? Each group of 3 is a period. The form where we write the number in groups of 3 separated by commas, that is standard form. Okay. All right, so I think there's an example for us to try here. Well, there's 2 here. In the first example, can you guys tell me how many periods are in this first number here? Okay, all right, that's a good start. 6, 7, okay. 1, 2, 3, 4, 5, 6, 7. 7 is the answer. All right. Again, guys, feel free. I like when you guys shout out and say the wrong thing. That's perfectly fine, right? And that's how we go here. It's like you're sitting for supper with your family and, you know, you're just talking nonsense. There's no pressure. Take all the pressure off. Just speak. It's okay. Okay, the second example says write the number in standard form and how many periods. Okay, so let me just do that one. It's quite straightforward. Okay, someone gave an answer already. 2, 3. Okay, 3. All right, let me check for myself. You guys are stressing me out a little bit. 7. I already did the wrong thing. 7, 6, 7, 8, 7, 6, 5, 6, 7. All right, you guys agree with that? Right, so that's standard form, 3 periods, right? 3 groups of 3. Okay. All right, questions? All good. Okay. So that's that. Okay. Also, we should probably see what we're doing with the breaks. Some people need 25 minutes with 5-minute breaks. Some people like to go 45 minutes with 10 to 15, I think 15-minute break in between. Do you guys think you can manage 45 minutes at a time? Okay, I'll check up regularly and see if you guys are managing. Okay. Expanded form. Now, this is a thing where you get marks for literally doing nothing here. There's very little work to be done here. Expanded form, don't confuse it with standard form. Right? It's a different thing. Expanded form is best learned with an example. If you have a number 264, expanded form is just 200 plus 60 plus 4. Right? It's the simplest thing you could ever do. Okay, guys, when you come in, please have a seat. People behind you trying to see the lecture. All right, thank you. Okay, so let me just say that again, and let me highlight the part which is important. This right here is the main thing. If all you know is this, that's all you need. All right, write the number 264 in expanded form. This is 200 plus 60 plus 4. All right, straightforward. That's all you need. And these things sometimes come out for 7 marks, 10 marks, which we can't afford to lose, right? It's free marks. Yeah, they'll give you a big number because there's 10 terms. It'll be 10 marks. And sometimes they give 2 marks per term. Anyway, whatever happens, it's marks for nothing. Okay. Now, technically correct is also to write the number like this. I don't know why we have to do this, but you can also do this. 200s plus 6 10s plus 4 1s. If you write that, you'll get your marks. You can also do this. 2 times 100 plus 6 times 10 plus 4 times 1. Also correct. If you do that, you will get your marks. If you haven't seen this before, this dot is a multiplication symbol. Right? If you haven't seen it. Okay. So let's do an example. express this number in expanded form. I should also mention that when you come to a maths class, guys, I would like you guys to bring pens and paper so you can do examples. Today, do you guys have something to work on? Pen, paper, laptop, iPads, whatever you work on, whatever you want, that's okay. Okay, and then I'll give you guys, let's say 30 seconds to try this example. It's a short one. Write this in expanded form. Okay, guys, just check this against what you have. Check if it's correct. Okay, so all I've done here is I've written. You start with the 1 right in front, and then you count how many digits are after that. How many digits are after that? That's how many zeros we need to place. Right, so after the 1, we have 1, 2, 3, 4, 5, 6, 7, 8. So you write a 1 with 8 zeros. That's your first term. Right, that's what we get here. Second one is going to be the same thing. We do the 2. Go to the 2, check how many digits after that. 1, 2, 3, 4, 5, 6, 7. 7 digits, so you write a 2 with 7 zeros after that. Okay. It's the same thing throughout, right? You just check how many digits after the number and you write that many zeros. When you come to the 0 though, see there's a 0 in the middle here. 1290. Technically you can write 0, just zeros, but you don't need to, right? You can just ignore that term. If you see a 0, you can just ignore it. Okay. All right. Any questions so far? At 10 marks for free, right? 10 marks. It could be up to 10 marks. Yeah. Okay. Okay. Yeah, guys, don't laugh because some people get these wrong. So let's make sure we get the marks. Okay, it's easy marks, right? Easy marks. Okay, inequalities. I'm not going to spend too much of time on this because I think most people know what these mean. But let's just check. We have less than, we have greater than, we have less than equal to, we have greater than equal to. These are the 4 inequalities we will deal with. Okay, so let's just see, for example, if I wanted to place an inequality here, which way does the arrow point? This way or the other way? The other way, right? Not this way, that way. Okay.
So I'm saying this way because sometimes I get confused who's left and who's right, you know? Okay. So it points to my right. So yeah, okay. So it's this way. Right, you guys agree with that? Okay. So I'm just going to do a quick thing here, which I've done with every group. Sometimes people get confused with which way to point the thing. If you ever do, there's a simple thing to remember. It's just a bit of fun, right? Don't take it too seriously. Suppose I had a number like, pick a random number. Anybody? 7. Suppose I had a 7. I'll draw the 7 here. The 7 has an arm and it's holding a spear. There's a spear here. And a number smaller than 7 would be, I don't know, 2, for example. So the spear is going into the 2, and there's a lot of blood here, right? Killing. Okay, so the idea is that the big number holds the spear and presses the small number. So always remember, if you remember this picture here, the spear is stabbing the small number. Right, so it always shows you which way to point the arrow. Okay. If you want to remember it this way, you can. If it's too violent for you, that's okay. I understand completely. Okay. All right. Do you guys want me to leave this in the lecture notes? Leave it. Leave it. Okay, let's leave it. Okay, we'll take our first break at 8:45. You guys still hanging in there? Good. Okay, good. Estimation. If you read the section here in your module outline, it's guys, please in the back. I don't want to shout over you guys. Okay, thank you. 1.5, if you read the section in the module outline, it's very long, very drawn out and unnecessary. We've summarized the change one slide. That's all we need. Estimation, whatever. We just need to know how to round off, right? That's all we need. I'm sure we know this already. So I'm going to just ask you guys to rattle the answers off to me. I have an example here. Let me just zoom in a bit. Okay. So round the following to the nearest whole number. 7.7 to the nearest whole number is 8, right? 7.6, 8, 7.5, 8, 7.4, 7, 9.9, 10, 100.1, 100, 200.9. Perfect, right? You guys get it? Everyone got it, so I don't have to go over anything here. Okay. You guys are saving me time. I appreciate that. If anyone has questions, though, and you're afraid to ask, feel free to come to me during the breaks. I'm okay with that. All right. Okay, properties and laws of whole numbers. Right. Again, this is one of those sections where we just have to learn annoying things that replace words that we know already. Okay, anyway, addition property of 0 and multiplication property of 1. These are two things we have to remember. The addition property of 0 is summarized here in this little equation. Maybe I should be pointing here. People in the video can see. The addition property of 0 is summarized in this little line on the side. 0 plus a is equal to a. Basically tells you that if you add 0 to anything, it does not change that thing. Right? That's the addition property of 0. If you add 0 to a, your output is still a. It doesn't change it. Right? Multiplication property of 1, same thing. Anything multiplied by 1 gives you that same thing as output. 1 does not change anything under multiplication. Addition, 0 does not change anything under addition. Those are the two things here. Okay. Again, just remember these. You'll get marks for them. Okay. Have you guys in high school dealt with permutation and association? Some of you have. Some of you might have not. That's okay. So permutation is just a simple idea that says if you switch the order of an operation, it does not change the output. Like in this example here, we have, I'll just write it again, 3 plus 2 is the same as 2 plus 3, right? You change the order of the operation, but it doesn't change the answer. Both of these will still give you 5, right? It doesn't change anything. So commutation says change the order, it doesn't change anything. Okay, so I'll just leave that there. Now thinking about that, can you guys tell me, does subtraction commute? 2 minus 3, is it the same as 3 minus 2? It's not the same, right? That's correct, it's not the same. So we'll write it like this. 3 minus 2 is not the same as 2 minus 3. So subtraction does not commute. Okay. Does multiplication commute? It does, right? So 3 times 2 is the same as 2 times 3. So that does commute. Division doesn't commute. Okay, that's clear, I think. Maybe let me give an example that we can see more clearly. Let's say 4 divided by 2, not the same as 2 divided by 4, right? 4 divided by 2 gives us 2 on this side. On this side, we will get a half, right? Not the same thing. Let's separate that one. Okay, so I'll leave these in the notes. Sometimes it's nice to have this one example each so we can quickly recap in our minds what the thing means. Okay, that's all we really need to know there. Association, okay. Similar thing, except here we're dealing with brackets. Have you guys seen association before? Some of you might have. Okay, anyway, it's very simple. It just says that if you have something like, I'm just going to write the thing again. As I write it, it's easier sometimes. If I have 1 plus 2 plus 3 with a bracket here, that is the same as 1 plus 2 plus 3 with the bracket here. Right? That's all it's saying. These two things are equal. So with addition, we can move brackets and it doesn't change anything. Right? Do you guys think that's true with multiplication as well? Right? With just multiplication, no addition involved, only multiplication. Right? Okay. Common, some people say no. Some people say yes. What's the truth? Who knows, right? You can actually. Only if it's just multiplication. Right? Let's think about that. Let's think about that with an example. Again, I'm happy to be proven wrong, but let's check it. I'm pretty sure it's true. 4 times 2 times 2. Let's just do that with a bracket here. What does that give us? It gives us 8 times 2, which is 16. Let us move the bracket and see if it works. 4 times 2 times 2 gives us 4 times 4, which is 16, right? So with multiplication, it works. The reason why we sometimes think it doesn't is because if you have multiplication with addition as well, then you can't do that, right? Because then you have to consider the FOIL method and all of these things. So association works for addition and for multiplication, right? If you're not sure, just check with some examples, try to convince yourself of that. If you can't convince yourself, then come and ask me. All right. Okay. And there's an example here for you guys to try is multiplication associative. We just did want to check that. We did that above, not in the right place, but it's there. So let's just point that here. Okay. 8:39, just hang in there, guys. 6 more minutes and we can take a break. We're almost there. Okay. These are the kind of questions you'll probably be asked. Think clear. Okay, yeah. Example, were the following rewritten using commutation, association, both or neither? So let's try and do a few here just to see. The first one, you guys think that's, put your hands up for association. Yeah. Example 1. Hands up for commutation. Okay, a lot of votes for commutation. What are the other options here? Both. If you think it's both, put your hands up. If you think it's neither, put your hands up. Okay, those are all the options, guys. Okay. Anyone who's not going to put their hands up, no matter what I ask, put your hands up. Okay. All right. So the first one is commutation. Commutation, because all I did is switch the order, right? Nothing else. If you switch only the order, it's commutation. Okay, number 2, what do we think about that one? Association. Right? Do you guys agree with that? That's because the order stays the same and only the brackets move. So that is association. Okay, let's look at number 3. It can't be both. Oh, you mean number 2? Let's see, 1, 2, 3, 1, 2, 3. Yeah, the order doesn't. I mean, you could get examples where that happens, but it didn't happen here. Okay. Well, that's good. That's a good question. Okay, yeah, these guys are disturbing. Okay. Okay, number 3. What operation happened here? Commutation. Because all we did is change the order. It doesn't matter that there are 3 terms here. The order changed. That's all that changed. So that's commutation. Okay. Number 4 might catch us out. What do we think happened here? Both, right? It has to be both. Okay. And if you try this, you'll see there's a few different ways you can approach it, few different ways you can rearrange things to make it work. So there's no one set answer here. I mean, the answer is both, of course, but there's not one set way to get the rearrangement happening. So you can try in many ways and see how you do it. I think let's try and get at least one going here. Let's try one in case I confuse anybody. Okay, this is like a puzzle now. What if I take the 2 to the other side? 1 times 3 times 2. And then I commute within the bracket. No, that doesn't work. That's not one of them. Let's try again. Let's see the 2. What if I commute within the bracket first? Move the 3 and the 1. I think that's easier to do. So 2 times, and then I move the 3 and the 1. Change the order of that. So first I commute that. Then by association, I move the brackets. I think that works. 2 times 3 times 1. So first commutation, then association. Right. Okay. All right. So what about 5? What the hell is going on there? I would say neither, right? I would say neither for that one. So nothing really happened that puts in the category of commutation, association, or both. So neither. What about 6? This is just an equation, right? It's not really doing anything. So this is neither. And okay, not to waste time, you guys can check number 7 at home because that one looks like it's going to be some combination of things. Or maybe neither, I don't know, but you guys can check it at home. Don't want to waste too much time on the same thing. 2 more minutes, we're almost at the break. Almost there, guys, hang in there. Distributive property of multiplication. So again, this is what many people call FOIL. It just tells you that if you have a bracket with 2 terms in the bracket being added, like this, for example, 10 and 2, and you have a number on the outside being multiplied in. So this is the same as 3 times this, right? In case you don't know that, there's a multiplication there. If the multiplication is not shown, it's implied, right? If you have brackets and something in front, it's always multiplied. If they don't show, it's implied. So this is basically saying another way to simplify this is to distribute the 3. So it becomes 3 times 10 plus 3 times 2. And it also tells us that because we know multiplication commutes, this times this is the same as this times this. Like the order doesn't matter. So at the bottom, they switch the order to show you get the same output. Right? So it doesn't matter which way the 3 is. It's in the front, it's behind, it doesn't matter. The order doesn't matter, you get the same output. Okay, let me not drag this thing right to the end. 8:44, let's take our 15-minute break here. And when we come back, if I don't start the recording, someone please remind me, because I might forget. Okay, I'm here for questions. You guys can go have tea, coffee, whatever you want. You just now be back at 9. Okay.